All right, so today we're going to be doing 12.3, which is systems of equations with applications. So with applications, that means that the equation is not going to be given to you. You have to come up with the equation on your own using context clues. All right, so anytime you're solving for two separate variables, that means you're going to need two equations to do so. So however many variables you have is going to be how many equations you need to come up with, okay? So it says here, Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If the book costs $1.50 each and CDs cost $5 each, how much of each did she buy? So first thing we want to do is identify variables. So you can choose to use X and Y, but I'm going to just keep it with the letters, what makes sense here. So we have B. Oh, what was that? Somebody left? Oh, he went to the bathroom. Okay. I thought somebody came in. So we have books, and then we have CDs. Okay. So we know that the total number of CDs and books is 20, right? So we know that B plus C is equal to 20. And then we have some dollar amounts here. So we know that a book costs $1.50. So if we take the number of books that we buy and multiply it by $1.50 plus, sorry, that should be a B, plus the number of CDs we buy and multiply it by C, that the total amount of money is going to be what? $54.50. So do you see how the ones with the money went together, and then the other one is just the total number of items that you bought? So these are going to be our two equations. So you have the option to use any method you want to solve here. You can use substitution or elimination. I find in this case eliminate or substitution is going to be the easiest. So we get B equals 20 minus C by just solving for B. And then now that I know what B is equal to, I can plug that in for B into the other equation. Okay. So that's going to give me 1.2 times 20 minus C plus 5C equals 54.5. I'm going to use the distributive property here. I'm going to get 30 minus 1.5C plus 5C is equal to 54.5. I'm going to combine like terms here, so that gives me 30 plus 3.5C is equal to 54.5. I subtract 30 on both sides, which gives me 3.5C equals 24.5. And when I divide, I get 7. So your number of CDs is 7. So if the number of CDs is 7, that means we have how many books? 13 books and 7 CDs. And if you didn't know that, you could plug it back into this equation here to get B. So any questions about solving that system of equations using conceptual understanding? Okay. All right. Next one. It says, at a fast food restaurant, 4 cheeseburgers and 5 small fries have a total of 2,310 calories. And then 3 cheeseburgers and 2 small fries have a total of 1,330 calories. So we want to know how much calories each item contains. So this is a little bit of a different situation. We have basically two scenarios. Okay, we have this scenario here, and then we have this second scenario here. So we can use the information combined to get the values for what the calories are for each item. So let's say we say that cheeseburgers is going to be C and fries is going to be F. So what would be our first equation in the green? How would we set that up?
4C plus 5
Good. Equals 2,310, like that. And then what would be the other one? I put 4, it should be a 2. I'm going to go back and fix it. There we go. Okay, so we get here. Okay, now we're going to move on to the next one. Or not the next one, next part. So the next part is we're going to have to solve this system one way or another. You can use elimination or substitution. If you try to use substitution, you're going to end up with fractions, so I recommend using elimination here because it's easier. So what could I multiply the first equation by? That'll work. 2 works, or 3. Yeah, 3 would work if you want to cancel out the C's, and then 2 will work if you want to cancel out the F's, but either way is going to be correct. And then if we multiply the first one by 2, what are we going to multiply the second one by? Not 5, but -5, because remember our goal is to get them to be the same number but opposite signs, which will allow them to cancel. So I'm going to use the distributive property here, okay? So we end up with 8c plus 10f equals 4, 6, 20, is that right? And then the next one comes out to be -15c minus 10f equals, I don't know, I'm going to have to do that in the calculator. Yeah, 6650, and that's negative. So now that we have these, what can we do with them?
Cancel the F.
Yeah, these are going to cancel, and this is going to become -7c equals something.
Negative.
Negative, isn't it that? 2030, yeah. Divide by -7, and we get c equals 290. So the calories in the cheeseburger is 290. So now we have to find the calories in the fries. So we just go back and use one of the original equations to figure that out. So I'm going to plug it into that second one. So it's just a bunch of calculations. I get 2f equals, I'm going to subtract this over here in just one step to save time. Uh, 460, which means f equals 230. And this is calories. So don't forget to put units on there. So I always go back at the end and read the question just to make sure I answered the question. It says how many calories does each item contain, which we figured out both, so we're good to go. So does anyone have any questions about that? Yes.
Why you choose 2 and -5?
Because you could have also done 3 and -4, because that would have canceled out the C's. So with elimination, your goal is to multiply each or one of the equations by something that's going to cancel out one of those variables. Any other questions? All right, perfect. Okay, so the last one we're going to do today, it says a collection of dimes and quarters is worth $9.55. So how much is a dime worth?
10 cents.
Good. So if I take 10 cents and I multiply it by the number of dimes, right, that's going to give me the total price in dimes. And that's going to be plus what?
0.25Q.
Good. 0.25Q. Because that's going to be the amount of money in quarters. And that's going to be equal to 955. Now here's where the tricky part comes in. If the quarters were dimes and the dimes were quarters, their total value would be 760. So what does that mean if they're swapped around?
Oh, 10Q.
Yeah, exactly. So now dimes are worth 25 cents and quarters are worth what? 10 cents. And that, if that is the case, then it's 760. Okay? So now our goal is to solve this system of equations. So what I'm noticing right off the bat here is a few different ways you can go about this. What if I multiplied both of these equations by 10? Why would that be beneficial here?
$8 is the same amount as that.
Yes. So I can get rid of all those decimals in there. That's going to become just D. So let's say we do that. So I'm going to multiply both of them by 10. Positive 10. For now. Sometimes you got to do multiple steps to get there. Okay. So this one's going to become D plus 2.5Q equals 95.5. And then the bottom one's going to become 2.5D plus Q equals 76. So then from here, you can choose to do elimination or substitution. I'm going to do substitution now because I have one variable or two variables that have one as a coefficient. So I'm going to solve for q down here. And you could have solved for d as well. It's going to be the same idea. So now that I know what q is equal to, what can I do with that? Plug it into the other equation, right, for q. So that's going to give me d plus 2.5 times q, which is equal to that, all equals 95.5. And now I can just do the algebra. So I get d plus whatever that is, 190 minus 625d is equal to 95.5. These are like terms, so I can combine them. This is like a 1. So 1 minus 6.25 is going to be negative 5.25, right? And then I'm going to subtract this 190 over. So I end up with 95.5 minus 190, which is negative 94.5, which means d is equal to 18. And now that I know what d is, I can go back and find q, right? By plugging in right here. So q is equal to 76 minus 2.5 times d, which gives you 31, I think. Yeah. So that would be the number of each coin. So that means there's 18 dimes and 31 quarters. Why would it be a red flag if my end result had a decimal in it here?
You can't cut a dime in half.
Yeah, I mean you could, but it doesn't have a monetary value, right?
Yeah.
So just keep that in mind. Use like context clues to also check your work and verify if it makes sense in the end of the problem. Okay? And it also can't be a negative amount of something. Yes.
If you add do the math 18 dimes, would there be any way to check your work to go back to 9.55 or?
Yeah, you can plug both of these back into this, and
Oh.
if the two sides of the equation equal each other,
Yeah.
you know you did something right. Yeah, exactly.